Well, hi there, boys and girls. We're going to take a look at a power series question. And it's got a function defined by f of x equals, you can see this here, you have this in your packet, for all x in the interval of convergence of the given power series. A, find the interval of convergence for this power series and show the work that leads to your answer. Alright, so we have to do the limit as n approaches infinity of the absolute value of. We're going to take a look at this general term. This is what we use for our interval of convergence. There's our general term. We replace all of our n's with n plus 1. And then also got, I'm going to leave the x up here, x to the n plus 1. And then we divide by the original, so we're just going to flip that thing over. So that's 3 to the n plus 1 over x to the n times n plus 1. Okay, so let's see what happens here. I'm going to have the limit as n approaches infinity of, get everything lined up, I've got 3 to the n plus 1 over 3 to the n plus 2. Because n plus 1 is n plus 2. And I also have some x's. I've got x to the n plus 1 over x to the n. And then I've got my n's. I've got n plus 2 on top, and I've got n plus 1 on bottom. So let's simplify this thing. There's one more factor of 3 in the bottom, so that's going to be a 3 in the bottom. And there's one more factor of x in the top, so that's going to be an x in the top. So there's an x and there's a 3. And then I've got n plus 2 over n plus 1. Now as n goes to infinity, this n plus 2 over n plus 1, they match. The degrees are both 1, so it's the ratio of the coefficients. So that limit is just 1 over 1 or 1. And then times my x over 3. So this is what I have left over. This is my limit. And I need this to be less than 1 to find convergence with the ratio test. So what we're going to do first is multiply both sides by 3. And then I'm going to separate it. Negative 3 is less than x is less than 3. Now I'm going to check my endpoints. Let's take a look at our series up here. I've got the series n plus 1 times x to the n over 3 to the n plus 1. We're going, and we're probably starting this at 0. Yeah, we're starting. This is 0 going to infinity. All right, so I've got to plug in my endpoints. If x is negative 3, let's check that out. So we're going to plug negative 3 in there. If x is negative 3, it works out to be negative 3 to the n, and then times n plus 1 over 3 to the n plus 1. And so I've got this series here. So let's pull out a negative 1 to the n. So that's the series negative 1 to the n times 3 to the n, n plus 1 over 3 to the n plus 1. And then those will cancel, which will leave me just a 3 down here. And I've got an alternating series. But the problem is, it's not decreasing. N plus 1 over 3 just gets larger and larger and larger. So even though it's alternating, this is not a convergent series. So that's going to diverge if x is negative 3. Then let's plug in x equals 3. If we plug in x equals 3, we're going to get 3 to the n times n plus 1 over 3 to the n plus 1. We're going to have this series. And then that cancels with that, leaving a 3 down here. And then I've got an obviously divergent series as well. So that's also going to diverge. So my interval of convergence is right here. I do not put an or equal to on either one of those, the 3 or the negative 3. So we've answered part A. And so I'm going to show you the 4 points. We got 1 point right here for setting up our ratio test. We got 1 point right here for computing our limit. We got a 3rd point for checking our endpoint, so I guess I'll get that here. And then finally my 4th point for negative 3 to 3. Alright, so let's take a look at B. B is asking me to find the limit as x approaches 0 of f of x minus 1/3 divided by x. Well, let's find this series. Let's do f of x minus 1/3. Since f of x was 1/3 plus 2 over 3 squared x plus 3 over 3 cubed x squared plus dot dot dot. F of x minus 1/3 would be, subtract 1/3 from both sides. Well, that would be 2 over 3 squared x plus 3 over 3 cubed x squared plus dot dot dot. And then to divide through by x, that just means we're going to divide an x out of everything. So f of x minus 1/3 divided by x would be, take an x out of every single term over here. You're going to get 2 over 3 squared. The x goes away. And then plus 3 over 3 cubed. X to the first, we divided an x out. And every term after that is going to have an x in it. So we want to find the limit as x is approaching 0. So if we plug in a 0 for all these x's, that limit is going to be right there, which is 2 over 3 squared. So that's going to be 2/9. That's my answer to that. All right, I had to pause that. I wanted a little thicker line. Yeah, that's a little bit better. All right, so now let's go ahead and do part C. Part C says to write the first 3 non-zero terms and the general term for an infinite series that represents the integral from 0 to 1 of f of x dx. That means I'm just going to go term by term and integrate that series. So let me rewrite what f was, because I'm way down underneath that question. F of x was 1/3 plus 2 over 3 squared x plus 3 over 3 cubed x squared plus, and then the general term was n plus 1 over 3 to the n plus 1 times x to the n. So what we're going to do is we're going to integrate this. So I'm going to integrate f of x. I'm going to integrate this side, and I'm going to integrate this side. So we're going to add 1 to the exponent, divide by that, and we're going to go from 0 to 1. So let's take a look at the integral. The integral would be 1/3 x plus, now when we do the 2 over 3 squared x, when we integrate that, I'm going to add 1 to the exponent and divide by that. Adding 1 to 1 is 2, and dividing by 2 is just going to take away that 2 right there. So I'm going to have 1 over 3 squared x squared. And then I'm going to have, when I add 1 to this exponent and divide by that, it's going to cancel that 3 as well. So that would be 1 over 3 cubed x cubed. And I'm supposed to write the first 3 non-zero terms. 1, 2, 3. There, I have done that. Now I also have to do my plus dot dot dot. I'm going to integrate this. When you add 1 to n, you get x to the n plus 1. And then when you divide by n plus 1, it cancels that. So it's just going to be x to the n plus 1 over 3 to the n plus 1. There's my general term. Now I'm going to evaluate this between 0 and 1. So I have to do this evaluated thingy between 0 and 1. So we plug in the 1 first. So that's 1/3 plus 1 over 3 squared plus 1 over 3 cubed plus dot 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 all the way out to 1 over 3 to the n plus 1 power. Then we plug in a 0. If we plug in a 0 for all of these x's, I'm going to have nothing but zeros there. Okay, so there is my answer to that. And I have to, I guess I need to plug in my 1 for my x right here. So I'm going to show my general term 1 over 3 to the n plus 1. That's after the plus dot 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 there. All right, part D. Find the sum of the series determined in part C. So I have to find the sum of this series. Well, you should see that this series is obviously a geometric series. I have a first term, which is 1/3, and I have a common ratio, which is also 1/3. We're multiplying by 1/3 each time. So my sum is going to be my first term divided by 1 minus that common ratio, which is 1/3 divided by 2/3, which is 1/2. So there's the answer to that one. Okay, so let's go on to this next question that we're supposed to do together, which is 2004, Form B. And here I've got a Taylor polynomial that's already been written, and it's centered at x equals 2. And I have to find f of 2 and f double prime of 2. Now, for a Taylor polynomial, third degree Taylor polynomial form, it looks like this. F of 2 plus f prime of 2 times x minus 2. and then plus f double prime of 2 over 2 factorial times x minus 2 squared, and then plus f triple prime of 2 over 3 factorial times x minus 2 cubed. So what is f of 2? Well, f of 2 is right here as this constant term, so that's fairly easy. F of 2 would be 7. Now what about f double prime of 2? F double prime of 2 is not the coefficient of the x minus 2 squared term. It's f double prime of 2 divided by 2 factorial worked out to be negative 9. Negative 9 is the coefficient of your x minus 2 squared. So I'm going to write down that f double prime of 2 divided by 2 factorial is the coefficient of the x minus 2 squared term. So I'm going to multiply both sides by 2, and I'll get that f double prime of 2 works out to be negative 18. Well, that wasn't that bad. All right, B. Is there enough information given to determine whether f has a critical point at x equals 2? If not, explain why not. If so, determine whether f of 2 is a relative max, a relative min, or neither, and justify your answer. Well, a critical point, we need f prime of 2 to equal 0 or undefined. So let's see. In our general term, our general form, f prime of 2 is the coefficient of the x minus 2 to the first term. Let's look and see. Oh my goodness, it's not there. There is not an x minus 2 to the first term. That means that f prime of 2 really was equal to 0. So yes, there is a critical point right there because f prime of 2 was 0. Now, can we figure out if that's a relative max, a relative min, or neither? Well, they sort of made me do that in A. I figured out that f double prime worked out to be negative. Since f double prime of 2 was less than 0, that means we are concave down at a critical point. And if we are concave down at a critical point, that means we have a relative maximum. All right, part C. Use t of x to find an approximation for f of 0. So we centered this at 2, and so we want to find out what f of 0 is approximately equal to. Now you got to be careful with your equality signs here. F of 0 does not equal t of 0. It's approximately equal to t of 0. So we're going to plug 0 in for x into this right here. And if you plug 0 in for x, you're going to get an answer of negative 5. You can plug that in, but I've already done it, and I know that it's negative 5. And then it asks, is there enough information given to determine whether f has a critical point at x equals 0? Well, just because t of 0 is negative 5, that doesn't mean f of 0 is negative 5. Nor can I find any derivatives for f at 0. All of this information up here is centered at 2. I've got f prime of 2, f double prime of 2, f triple prime of 2. I can figure all of those out. But I do not know, and nor can I find out, f prime of 0. F prime of 0 is approximately equal to question mark. I have no way of finding that. So since I only have data points of f prime and f double prime at 2, I cannot answer this question. So no. I need f prime of 0, and I would also need f double prime of 0, and I cannot figure those out. All right, D. The fourth derivative of f satisfies the inequality such that the absolute value of the fourth derivative is always less than or equal to 6 on the closed interval from 0 to 2. Use the Lagrange error bound on the approximation f of 0 found in part C to explain why f of 0 is negative. Well, just because I can't find f exactly, I can do an error bound here. Now, you should know that your error is less than or equal to, we have this maximum value of the next derivative divided by, well, it's going to be, the next derivative is 4 factorial, and then times x minus a to the fourth. That's our formula since we stopped at a third degree. This is our Lagrange error bound. Well, they just told me what n was. The maximum value of the fourth derivative is 6. It never gets above 6. So that's going to be 6 over 4 factorial. Now, what is my x? I approximated it at 0, and I centered it at 2, and we're going to raise this to the 4th power. So let's see what that works out to be. Keep in mind I'm doing an absolute value, but this still works out to be positive. So 2 to the 4th is 16 over 4 times 3 times 2 times 1. My error has to be less than that. So I've got 3 and 2 is a 6. 16 divided by 4 is 4. Okay, so the most I could be is 4 off. Now what does this mean? I thought that f of 0 was negative 5. Since the maximum error is 4, I know that negative 5 plus 4 and negative 5 minus 4, that's worst case scenario. So somewhere between negative 9 and negative 1, that's where f of 0 actually has to be because of this error statement. I approximated it to be negative 5. My error is 4, so you go plus and minus with your error, and you can see that f of 0 has to be negative. It's somewhere between negative 9 and negative 1. Therefore, f of 0 is negative. So you're going to work some examples tomorrow that are sort of similar to these, and I will see you guys then.